All right, so in the last episode of Pong 8, we ended up taking a look at implementing scoring. So now we can detect whether the ball's gone past the left or the right, flip for you, right or left edge of the screen, and increment the correct player's score accordingly. Now the game goes on forever. We could do that and it would go on, and there is no end, there is no victory, and we haven't quite got to the victory yet, but I wanted to implement a small feature for serving the ball back to the correct player depending on who scored. Because currently it's the case that if player 1, for example, scores on player 2, player 2 doesn't serve the ball back to player 1, it's just random. The ball resets and goes whichever way it wants to. Instead, what we're going to do is have the ball go in the direction of the opposing player. So if player 1 scores on player 2, then on the next turn, the ball is going to go back towards player 1, just out of fairness, just to make the player who just scored have to work a little bit before they get their next point victory, perhaps. Before we end up covering much of the code there, I want to take a look at state machines. So far, we haven't really dived too deeply into any of this stuff, but a state machine is really simple. It's just a diagram that really maps sort of individual states of something, whether it's a game, maybe it's an entity in the game, it can be anything, a machine. It maps the individual states and the transitions between them. So for example, here is a diagram of what you might see in a platforming game, and it's something that we'll probably see very similar to in Mario when we get to the Mario half of the track. But we see we have standing, for example, here right in the center. And if someone presses B, which is marked by this arrow here, and it's written as well, they go into the jumping state. And so these blocks, these boxes are states, and the arrows and the words written on them are the transitions. So that's what's really important about a state machine, is you can model sort of what something can do and how to get to those individual states pretty elegantly. Now, with this new update, we're going to implement serving to our game. So really, we're dealing with states in terms of game states now. We're not talking about entity-related states, which we will get into with Mario, but this is more or less the same exact way of thinking. And we don't have a really elegant way to model this either, but we will look at a different way when we get to the Mario track as well. So in this update, we're specifically going to add a serving state to the game. And there's a teaser, and the next one after this, we're going to do the victory update. So let's actually get to implementing serving functionality. So what I want to do is I want to have 3 states now. I want to have a start state for the very beginning. I want to have like a welcome message. I want to have a serve state such that player 1 or player 2 gets to serve the ball. It'll go in the direction of the particular player that scored on the other player. And then I want to have a play state for when the ball is actually in play and collision is happening between the ball and the paddles. So down here in the up draw function, I'm going to set a, let's do it right here. I'm going to have a bit of code that says love.graphics.printf. Let's just say hello Pong, or let's just say welcome to Pong. How's that? Welcome to Pong. And I'm going to set this is again printf, so it's going to center in the screen, and we're going to specify where it starts and the center, the column width of the centering. In this case, we're going to start it at the left edge. We're going to say that this should be, let's just say, not virtual, let's just say this starts at 20. And then I'm going to say the column size is virtual width, and we want to center the text. And I want another bit of text here that says press enter to play. That's going to be below what we just did. So it's going to be 0, let's say 32, virtual width, and center. Let's save it, run it, and we do indeed see welcome to Pong and press enter to play. And if we press enter, the ball does move. We can hit the ball back accordingly. Everything is the same as we've seen thus far. Back to the text editor. What I want to do now is I want to start keeping track of who scored against the other player. So, what I really want to do is keep track of who should serve, and then we'll decide who should serve based upon who scored. So let's go up to the very top here, and beneath where it says player 1 and player 2 score, I'm just going to say serving player, and by default we'll always make it 1, or rather, let's just make it math.random 2 equals 1 and 2. There we go. So it'll be a coin flip between player 1 and player 2 out of fairness. So let's go down to where we actually end up calculating the score. And so this is where we have player 2 scores, incrementing, player 1 scores, incrementing, the ball gets reset, and then the game state gets assigned to start. Now remember, the ball reset function actually does randomize the ball's dx. What we want to do is set that specifically depending upon who scored. So if player 2 score gets incremented, well then that means that player 1 should be the serving player, and the ball should therefore be set to ball.dx is going to be equal to 100. So we want it to go towards player 2. Accordingly, we want here in ball.dx to be equal to negative 100, and we want serving player equal to 1 and serving player equal to 2. Perfect. So now what we can do is go down to where our, oh, also another thing we want to do is set the game state to serve, not to start. And this will be important here in a second. So I'm going to go down to the very bottom again. Now this message that we have showing up at the very beginning, we only want that to happen when we're in the start state. So specifically I want to say if game state is equal to start, then do these things. Else if game state is equal to serve, then I'm just going to copy that line there. I'm going to say player, and then we're going to concatenate toString the serving player. So serving player, concatenate a apostrophe S turn. And actually, you know what we're going to do? We're going to copy this. I'm going to bring this down here. And I'm just going to copy this thing here like that. I'm going to say, actually, press enter to serve. I'm going to copy this here like that. So now we're going to have player X's turn and then press enter to serve written underneath only when it's the serve state. And then if it's the play state, then neither of those are going to operate just because of the way that we have configured our states here. And that should be everything. Let me just give it one quick look back again up here. So if the ball is less than 0, so if it's gone on the left, player 1 should be the serving player, and then player 2 should serve on the other side, and then the dx should be 100 if it's player 1, and negative 100 if it is player 2. So perfect. Let's go ahead and run this. Just make sure that everything is good. So I'm going to press enter to play. Whoops. Okay. Oh, you know what we haven't done? We haven't actually configured in our update phase of the key pressed phase whether it is player 1 or player 2's turn to serve. We go straight to start, actually. So what we need to do, or we go straight to play, rather. So in love.keyPressed, what we need to do is if key is equal to enter or key is equal to return and the game is equal to start, we need to go to serve. And then else if game state is equal to serve, then we go to start, and then we can get rid of the reset call there. So now when we're in the serve state, or rather this should be play, not start. Let's go ahead and do that. Then expected, oh, I had a syntax error on line 215. There should be a then right here. Save that, do that. Let's try it again, press enter. Player false's turn. Okay, well that is not what I wanted. So let's go over back to our code here, and let's go over to where we have this set. So toString serving player. Okay, let's go up to serving player. Oh, sorry. Equals 1 and 1 or 2. Sorry, I missed the little ternary thing there. So we need the coin flip, which is the math.random2 is equal to 1, and then the 1 or 2. So the which one it is if it's true and which one it is if it's false in that case. Let's try that one more time. Fingers crossed that it works now. And it does indeed work. So player 2's turn. So if I press enter, the ball should go to the left, and it went to the right. Okay, so that's interesting. Let's go back over here and make sure that that is working accordingly. So ball dx should be set to the right one. Let me just make sure that that works. Let's go over to ball dx is equal to, okay, so if the ball is to the left and serving player is equal to 1, we're going to reset the ball and set the dx to 100. Otherwise, we're going to set it to negative 100. Let's just run that one more time, just out of curiosity. So it worked that time, but clearly it didn't work correctly the other time. So let's just make sure this is working. So ball reset should set the dx correctly. Okay, I've realized, I think, what the issue is. It is that we establish a serving player in main at the beginning of the program, but we don't actually make sure that we choose the right starting velocity for that serving player depending on that coin flip. So what we're going to do is, I'm in main here at where serving player line is. I'm going to say if serving player is equal to 1, then else. And if serving player is equal to 1, I want to say ball, or rather, I should say down here. I should do that after the ball gets declared first. We'll say ball.dx is equal to 100, else ball.dx is equal to negative 100. Let's run this and let's test it out. So player 1's turn, so it should go to the right. Does go to the right. Perfect. Player 2's turn, so the ball should go to the left. Okay, it does go to the left. Let's restart it one more time just for good measure, just to make sure it works. Player 2's turn, so it should go to the left again. And it does go to the left again. So that was the issue. We had a coin flip at the beginning where we didn't actually specify the DX appropriately. And that's one thing that you need to do after you randomly choose the serving player. And that's really it for the Pong 9 sort of serving update. So we talked about state machines. We really have kind of a primitive state machine in that we're checking to see whether a ball has gone to past the edge of the side of the stage, in which case we're transitioning the state. That's really all a state machine is, the nodes and the transitions between the nodes. In Pong 10, we're going to actually use the score that we've started manipulating, and when a score goes past a certain number, 10 per se, although we'll probably check for a smaller number just for testing purposes, then we should have a message display, a victory message that says who the winning player was, and then allow the user to press enter to restart the game entirely. So we'll see you soon for Pong 10, the victory update.